Hello. I will not talk about sophisticated attacks today. I will not drop any new all day. What I will talk about are those good old Active Directory misconfigurations and bad practices that still get us today in 2019, making it easy for the bad guys to get into our networks and steal our data. Just over 3 months ago, we got a phone call from a client that asked for an assistant. They had some not explainable users that logged in and got locked out from the domain. We looked at their environment and we see an unmanaged device, that is a device that is not part of Active Directory, trying to get into the domain with multiple users. Some are not even part of Active Directory, and some are being locked out as a result. And we found one user that successfully logged in into the domain from that unmanaged device. We're showing it to the user, and the client is not impressed. He's more worried about the accounts that got locked than the one that successfully logged in. And we're trying to explain to him that there might be a relationship between the two. When we see the same account all of a sudden logging in to the CEO laptop and escalating privileges. And when we show that to the client, magically they started to worry, disconnected the device, and disabled the account. So that story is a result of those misconfigurations in Active Directory and bad practices. And that's what we're going to talk about. I tried to build the talk in a sequence event that makes sense, kind of the kill chain of owning your domain. So it usually starts with getting a local administrator rights and then starting to live out of the land and looking for any other assets within the organization using reconnaissance, and then escalating privileges, whether dumping hashes or trying to trick users to steal hashes, and then either passing them or cracking them offline. We'll speak about some of the Kerberos-based attacks, namely golden ticket and Kerberosing. And eventually attacks around domain controllers in general. And we'll end up with some ideas on mitigations and specifically the concept of adaptive enforcement. So this is a video screenshot from my first B-side. It was about indicators of compromise, and I thought it would be smart to dress as a detective because I spoke about intrusion detection or intrusion analysis. And so that's how weird I am. Uh, Other than that, my background is from threat intelligence and also identity and access management, and specifically Active Directory assessments. That's what I'm talking about today. So we said the first step will be moving from the user space to the system space. And that is an essential way usually to start performing effective reconnaissance and move laterally. There are multiple ways to do that. I'm not going to get into the techniques here, but you probably heard of hijacking high privilege programs or bypassing the user control access. There are other ways to do that. And local administrator, the user 500 is not necessarily going to be a domain administrator, or probably will not be a domain administrator, but will help us to as a first step. So just to be clear, local administrators could be not even a domain member, and some domain members are already local administrators. So we'll just keep that in mind. When I get the local administrator access, there's good chance that it will help me to move laterally because Microsoft made it easy for administrators to have the same password for local administrators across the domain. So in Windows 2008, group policy preferences was introduced. And within the group policy preferences, among other values or benefits for administrators like changing environment variables, updating file, modifying registry keys, there's also the ability to handle local administrator password and to make it the same across the domain. Anyone think this might be a problem? Yeah, I agree. To make things worse, Microsoft was allowing administrators to expose the password within Active Directory, for example, in a VB script. Later on, they realized it's a bad idea. And around 2012, they started to move from clear text to encrypted XML file. The XML file sits on sysvol with an AES 256-bit encryption. That was a good move. However, Microsoft dropped the ball and published that AES key in MSDN, which is their open portal. So everyone could get access to that key. And if they get a hold of the XML file, they can decrypt the encrypted file. Eventually, Microsoft realized that local admin passwords should be probably managed automatically and came up with LAPS, which is the Microsoft Local Administrator Password Solution. So in order to make sure you don't have the same local admin password, first, you should implement the GPP security update. That's an old patch, but we still see some cases where it's not implemented. And even after you implement it, you still need to remove the XML files. So the patch is not removing the files for you. You need to make sure you remove the files and any other scripts that use to change password. Like I mentioned, use Microsoft Local Administrator Password Solution or any other password management solution. And if you create endpoints that have the same image, make sure you change the local administrator password. Now, in some cases, you don't even need the administrator account, just disable them. And obviously, there's also the local guest account that not necessarily needs to be enabled. If you can, disable them. So once we get local administrator permission, we can use some internal reconnaissance tools. The scanning tools like Nmap, Nessus, Nextpose, and there are query tools like Bloodhound, and there could be some other type of internal reconnaissances. So to look for the domain controllers, there are some ports that are unique. The unique ports for the domain controllers is the LDAP global category. So LDAP port 389, it could be enabled on other devices that are not necessarily Active Directory domain controllers. But this one, 3268, will, in a good or high probability, will find you all domain controllers. This is an example of Nmap flags that can be used, some of which are more noisy than other. In other words, some of them will help you try to avoid detections. So you should be aware of that as well. For example, the sync, ACK, and reset is a pretty unusual behavior and noticeable noisy in the network. Other tools can help with querying Active Directory entities. So Bloodhound is a recon tool based on PowerView for data collection. It scans for domains entities, including members of groups, both users and endpoints. And most importantly, it can help you find the shortest attack path for the user to a domain admin. So let me show you an example. You can see here the source, the initial victim is on the top, and the target is on the bottom. And in order for me to get into the bottom, Bloodhound shows me that there's basically 2 hops that I need to go through, escalate the privilege to administrator, and finally get to my target. The last tool for the reconnaissance, the internal reconnaissance, is just intelligence gathering in general, which is similar to what you do prior to attacking a company, right? Looking for exposed passwords, looking for account descriptions within Active Directory, for example, executives, user roles, looking for stale accounts, accounts that haven't been used for a long time, probably can be leveraged. Stealthy administrators, those are users that are not part of the administrator group, but somehow can manipulate administrator by resetting them. And look for weak password, right? Guess what could be a good password to spray at this time of the year? Summer 2019, maybe the company name with the date. Those easy to guess passwords. And of course, compromised credentials. Help reducing the attack surface and reduce the or mitigate some of the internal reconnaissance capabilities. starting by looking for those scanning tools and for querying tools, both the ones that go to Active Directory and then the ones that go directly to the endpoints. Maybe create some signatures within your IDSs, maybe to put some monitoring sensors around the Active Directory and the domain controllers. Users are still the weakest link. Help training users, both on password, best practices, and on social engineering. And from a network perspective, make it hard for those tools, the scanning tools and query tools, to reach all your networks by segmenting the network. Make sure the strong password policy, and you have some weak password or phrases blacklist. That's going to help with gathering some more information over there. All right, so we got a local administrator right. Now we know where we are, we know where we want to go. We did some intelligence gathering. Now we need some hashes. Well, thankfully, Microsoft helped us with hashes and give us some tools to play around with. First one is LSAS. LSAS is the Local Security Authority Subsystem Service. And that is the tool within each and every client you have that enables your SSO to Windows devices. That's what prevents you, or make sure you don't need to type your credentials every time you access a new drive or a new host, because it keeps your credentials within memory, as you can see, in multiple formats. It stores Kerberos tickets, which we will talk about in more details later. It stores NT hashes, which wrongfully a lot of people refers to as NTLM, but it actually is an NT hash. And it does store the old protocol, the LM or LAN manager hash, which is not really in use anymore. So the main two protocols for authentication we look at is NTLM and Kerberos. Now in 2016 server and a Windows 10 client, Microsoft introduced Credential Guard, which helps with preventing easy access to the LSAS process. So it would be hard to dump the files and dump the process and dump the hashes. So now, instead of sitting in a kernel mode, it sits in a separate, isolated mode. It's built over Hyper-V, so it cannot really be ported backwards. So if you have 2012 servers or Windows 7 clients, this cannot be implemented on those. Anyone by accident having 2012 servers in their environment? How about Windows 7 clients? So we just need one machine with that operating system in order to keep on dumping the hashes. But for the others, it's starting to be more complicated, but not impossible. So Benjamin Delpy, the creator of Mimikatz, automated a lot of the processes, including pass the hash. So if you go into Mimikatz and you try to dump all the hashes. If you're not using credentials card, you will get all the hashes here. Now, if you use credential card guards, there's still a way around it, and that's using the security support provider, the endpoint, or SSP. The security support provider is, and this is just showing you here how we, so this is an example of a Windows 10, and what you see here is running Mimikatz as a process. You don't even need to run the application. And then injecting a custom SSP, which means now when the credentials are getting out of memory, they're going to go through Benjamin Delpy's custom SSP versus the default SSP. And so what you see here is Mr. Delpy is accessing a remote machine, and when it accesses the remote machines, it gets the credentials in clear text because they're going through the custom SSP. So the only difference here is using Mimikatz would be waiting for users to leverage their access versus waiting for versus just dumping the credential from memory if it's in earlier versions of Windows. So another source for hashes is the ntds-dit file. That file sits on each domain controller, and it's the database of Active Directory, if you will. This is a structure of the data store and the components they're accessing, NTFS. And it's important to mention that there is a registry key that includes an encryption code that's called syskey that encrypts the sensitive data within the database. So in order for us to steal the hashes there, we just need to get a hold of NTFS and this syskey, and we're golden. And there are multiple ways to do it. A nice, cool way is a tool by Michael Grafneter that is called Get ADDB Account. The ingredients are the ntds-dit file and the key, the syskey. We saw here, right, that you won't be able to just copy and paste the ntds file from the server because it's a continuously accessed by an active process. So the way to do it is to create a shadow copy of the file or the entire drive, then copy that into an external server. Going to make it a little bit faster here. We can skip it a little bit. Eventually, I need to export the registry key that has the syskey to decrypt the encrypted sensitive data. And then this is Michael Grafenter tool here. I identify the key, and then I can run it. Oh, one more step that needs to be done is, since I copied a file while in process, I might need to recover some of it. So this is where I'm recovering it. And then after scanning, checking for integrity, recovering whatever needs to be recovered. you get this rain of hashes going down. So mitigation for dumping hashes, when it comes to dumping hashes from LSAS, remember that LSAS keeps all the users that logged in into your machine since last reboot. So you want to make sure you separate accounts from privileged users, privileged groups. So if someone is getting into your machine, it doesn't have privileged accounts cached in memory. For privileged users, we recommend to use the latest OS. So you have credential guard implemented. And regardless, you still want to make it hard to crack those hashes by including long characters for privileged users and secure your backups so nobody can get a hold of them and steal NTDS that did. Now, one way was to dump the hashes. The other way is to somehow trick the victim to authenticate with your machine and steal the hash at the same time. I will start with an example. Well, SMB is a great way to do that. SMB authentication works as you see here. It encrypts a challenge with a password. So if you want to access a shared drive, you're getting a password. Basically, you're getting a challenge. You need to encrypt the challenge with your password hash, and by that, identify yourself, and then you get access created. So if I get someone to click on a link that has a image tag with a file drive, that will generate an SMB access request. So it could be an HTML web page, or it could be an Outlook form, it could be an external SMB server, if the SMB port 445 egress is allowed, or it could be an internal, and Responder has already a model for it. And if you are collecting the password hash, you can start cracking it offline. But that's also how you can leverage Outlook custom forms injection attacks. If the attacker steals the username and password of one of your users, then the attacker sign in with that user to exchange mailbox. The attacker can create a custom mail from a template, and then the email is received, the form is loaded, and the application typically installs some kind of a malware, such as PowerShell Empire, locally on the user's machine. And then the malware allows the attacker to steal users' password and other credentials from local machines. This is how it looks on Wireshark when loading an OLE from a remote SMB server. You see here the session key is the SMB encrypted challenge. And the only action that triggers this negotiation is Outlook preview in some cases. There's a fix for that, but in many cases, an unpatched Microsoft Outlook will trigger this negotiation without an interaction with the user. And again, once it's once you get the hashes, you can crack the password offline using the Kali Linux, for example. John the Ripper or Cain or what have you. So to prevent stealing hashes using SMB, you want to have the latest version of or patches on your Microsoft Office, so it processes OLE correctly. You want to block inbound and outbound SMBs 445 to your network borders. There's no real good reason to have 445 allowed outbound. Definitely NTLM v1, which is a much easier way to crack your hashes, shouldn't be allowed. If there is a legacy systems that for some kind of reason need that, it should be really well isolated within your network. And again, make sure you have sufficiently complex passwords so it makes it a little bit harder, maybe a little bit more than a little bit harder for the users, for the hackers to decrypt the data. So LLMNR is a legacy protocol that we still see enabled that helps to steal hashes in a different way, where the idea is to get the victim sending an incorrect SMB shared address to the DNS, look for it. And then the DNS server respond with that's not me, not found. Then the victim, if LLMNR is enabled, will send a broadcast on the same subnet to see who is at specific shared drive. And the attacker will tell the client that that's him, and will make the victim send him an NTLM hash. Attacker will capture the hash and then send them an error back. There shouldn't be any reason for you to have this protocol enabled. You can enforce it via group policy to disable it, and follow the principle of least privileges, so users cannot leverage too much this attack vector to begin with. And last example related to SMB is SMB signing. SMB signing is a feature through which communications using SMB can be digitally signed at the packet level. Digitally signing the packets enables the recipient of the packets to confirm their point of origination and their authenticity. So SMB signing can help with confirming the original point, but for some kind of a reason, SMB signing is disabled. Most of the times we're looking at the clients. There's actually some good blogs out there that helps administrators to disable SMB signing if they don't know how to do it. So they're making it even easier for the attackers. Again, so relaying the attacks, when the SMB signing is disabled, then there's no way to check the authenticity of the origin, and therefore a man-in-the-middle attack is enabled. So the way it works is somehow we get the victim to access our authentication as an admin, and we pass this request to a target. The target is sending back into the attacker a challenge. The attacker forward this challenge to the victim. The victim encrypt the challenge with the hash, and then the attacker forward the encrypted challenge to the target and get an access. At the same time, say bye-bye to the victim. So simply enable SMB signing. You can enforce it via group policy. And again, if you cannot do that for any reason, generally as a good practice is follow the principle of least privileges.